Hi there, Pavish. Hi. Welcome. Okay, so what should we do today? So many different things to pick from. Too many, some would even say. Hi, Black Thunder. I just did some website work. Could do some more of that. I think actually mainly I should first record I think I should first record for a video and then animate two of them. And hi Nandi, hi, welcome. Yeah, okay. Okay. Yesterday we scripted this, if you recall. And so let's get started to work on it. What's up? Not much, just working as always. Ugh. Okay. Let's give it the classic make it floor texture. Gotta have the glow. I have a fair bit of a headache, I'm not gonna lie. But with enough coffee and with enough distractions, I'm certain it's gonna pass.
Apparently there's a secret third mute button on this headset.
Oh, hi there.
I spent the last 10 minutes talking to myself, apparently. Guess what?
What?
Car gets painted today.
Oh yeah, I saw the picture. That's nice.
Suspiciously paint-free car.
Alright. That's something. I wonder how long I'll be able to go through today. I've been really just... Something's off with me as of late. Yeah, I think it's the heat. There we go. Why is there a shortcut for that? Piss off into the corner where you belong. There we go. Okay. This should work as a setup. Damn it. I set it up manually. I don't remember how to set it up. Can I new sequence from clip? I can. Beautiful. Alright, bullet. I will need to first start by recording the entire video, because that's usually how I like to do my animations. So, let's try that. Test 1, 2, 3. Okay, great. This one might take a bit, because the script ended up much longer than I originally envisioned. But hey, should be only a bit. Come on, wake up! First, I would like to say that programming and programming are not quite the same thing by introducing you to the concept of abstraction. Abstraction basically tells you how many layers of separation are there between the actions that your hardware takes and the actions that you program in. For example, let's say that you'd like to take a string and separate it into multiple strings based on the spaces. How would you do that in Python? Well, you do it like this. Simple, easy, convenient. One issue, how does your computer split the strings? No idea. And I mean it. If you pick any programming language above basically Rust, you don't actually know anything about how the computer programs it in. You don't actually have to know anything about how computers to program. Fuck! No idea. And I mean it. If you pick any programming language above basically Rust, you don't actually have to know anything about... God damn it. No idea. And I mean it. If you pick any programming language above basically Rust, you don't have to know anything about computers to program in them. To program it. I'm fine. Shut up. It's fine. Who wrote this? Who wrote this shit? No idea. And I mean it. If you pick any programming language above basically Rust, you don't actually have to know anything about computers to program in them. And you can make programs as elaborate as you want. And it certainly does take skill, it just doesn't require any knowledge about computers. However, once you go below Rust to a place like C, you do actually need to know a fair bit. And that's because in C, you can't just split a string, and instead you have your char pointer representing the string, and you need to scan it, find how many spaces it has, then allocate that many char pointers, and only then start copying them over. This requires at least basic understanding of memory management, and basically means that you need to understand the structure of the memory as your processor is moving things around. But we can go lower. Because this still abstracts the workings of your processor. Your processor has registers inside, abstraction which gets removed with assembly, which then gets removed in machine code, etc, etc. This isn't the main topic of the video, so I won't spend an eternity talking about it, but basically, here's the rule. The higher up you go, the easier it gets, but the slower your code is. The lower down you go, the more difficult, but the faster the code. But at the same time, low-level programming languages have a certain charm to them. A charm which I would like to show you in this video, because in this video will happen in my favorite programming language, that is C. The first chapter. Took me 7 tries on that one line, but it's fine. We can start with this. This is enough. Alright. That's not 1/3, that's a lie. That's page 1, there's 7 of them. This is meant to be a quick and simple video. Why is the read so bloated? Well, at least it woke me up. That's something. Okay, there we go. Let's get to work then. All right. This is too much. It's kind of unreadable. Okay. Slightly more readable. Fine. I'm really in the mood for some science. The problem is that I have a job I need to do. Annoying. Alright, so here's the plan. I'm gonna be rendering one video whilst I'm gonna be working on the other video, and if I'm finished the animation for the other video before the first one renders, then I get to work on the fun stuff. Fuck. There we go. Okay. There we go. Done. Now we get to do something fun. And by something fun, I obviously mean this. This right here is a very basic setup for a malloc. I'm not quite satisfied with it, but yeah, I need to change it up. It'll be a very basic setup for a malloc that we're gonna use. Ah, right. Next doesn't exist. Is3 is a 1. Yes, it is 3. Honestly, maybe is taken would make more sense. Ah, whatever. If it doesn't break, it doesn't break. And then its size is, well, everything.
Memory allocation is such a funny concept when you abstract it.
Yeah.
How do you remember something? I don't know. Have you tried putting it in a box?
I mean, that is what it is.
Yeah. And then allocation is just how many boxes do you have? How big are the boxes?
It's so weird making everything from scratch. They're like these very basic things that you need just don't exist because you haven't made them yet. Oh, fuck me. Alright. So we have the current.
Day on computer science. I went outside to pick up some sand because I don't have any silicon wafers.
Listen, I'm moving in that direction. One day that's gonna be one of the live streams. I'm sick of how much unnecessary shit there is in my silicon chips. I'm making my own.
It turns out there's a lot of necessary shit in my silicon chips.
I mean, hey, I've been moving in that direction for a while, and at this point, I'm on the kernel level, right? Like, past kernel level, you do need to start making
when
hardware.
My computer thinks without permission, so I'm making it out of gears.
Genuinely, the only thing lower than this is firmware, which I'm pretty certain depends on hardware already.
Going in the all hardware direction would be a pretty funny turn of events.
Eventually. Give me like 2 more years.
I mean, you already have a 3D printer.
I don't think that's enough. What's funny is that
It might be.
I did have, it's not in my place, but I do have a CNC machine, a simple one, which I could use to make PCB boards. I also know a guy who has a laser engraver that would be better at making PCB boards. Right. If the current is not equal to null, while current is not equal to null, this would reach the problem effectively.
Laser engraver, I hardly know her knower.
Fuck off. It took you such a long time for that too.
Yeah, because I could go 3 ways with it.
You shouldn't be proud of that one.
I'm not proud of it.
Good.
It's still funny though.
It is. Okay, so what this effectively states is, if we have a free block, and that block has enough of a size to accommodate whatever it is we want it to accommodate. Oh, it's so headache-inducing, my goodness. Then what? Well, then we want current. First of all, is free is the easiest because we can just set that to 0. That one is simple. Then, size is equal to size. Yes. And then what do I do with the next? I'm pretty certain this. Oh, what if you try to be too clever for your own goddamn good? Char pointer this sucker. I think this should work. This is so annoying because if I'm wrong, it's gonna break. And I won't be able to actually check if it broke for the reason I thought it would. Fuck. Size of block? I'm pretty certain. And by pretty certain, I mean not certain in the slightest. My graphics card almost died just by running that single animation. Great. Okay, great. No, this is the website. This one. I am like solid 7% certain it's gonna work. My confidence at an all-time high. Let's try it. Basically, what I should be able to do is I should be able to just do text is equal to malloc, and then 6. Text 0 is equal to m. 1, 2, 3, 4, 5. Oh, 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 plus Thunderlip. Yeah, about that. It kind of about that. I kind of can't use that. Funny story. It kind of doesn't exist. Implicit declaration. Oh no! It's fine. It's all good. I just haven't included the memory. All right. Okay. Char pointer. My goodness, you're so picky! Stop being so picky! There, it's a block pointer. Happy now? My goodness, null is undeclared. That, you know what? That is actually pretty fair. Null is undeclared, that is true. Damn. Yeah, I'm gonna make... I was about to say something, but then I realized that's not exactly what it means. What are you working on? My own kernel. Of course, null is not gonna be a thing. Next. There's no next. This one I'm just gonna remove for now. Wait, no, I'm not gonna remove for now. I need to keep it. Okay. Multiple storage classes declaration specified memory H. What is your problem here? Okay, so this one should be just external, I guess. Previous declaration block pointer, whereas this one is static. Static needs to be non-static declaration. Fine. My goodness, that actually worked. Okay. I mean, I don't know if it worked. That's the problem, right? No idea if that worked. Let's try it. Let's try logging text kernel. So now what we should do, we should see time, yellow note, arrow, make it, arrow kernel after this text. That's fine. Okay, that's a dumb error. All right. Well, that's really broken. Huh. Okay. That's that's really broken. Wow. Oh fuck. Undefined reference to malloc. Oh, you bloody... You're fine. Trust me, you're fine. You just need the memory here. You just need to remember. Just lumberjack, yeah. Okay, great. So basically, we're looking for what? The heap start. Oh, I didn't initialize the malloc. Why didn't you tell me? It's fine. Everything should be fine, I think. I don't know. We're about to find out. Surely everything will be fine. Good, take that! That's good. The one slight issue. I still don't know if the malloc works. It could work, it may not. Another. If all of a sudden we start experiencing wild memory corruption, that probably means it doesn't work. I mean, it did what I expected to do, Flash, that's true, but... Big note, there is no way for me to test for sure. There is no way for me to test for sure if it actually works. I will just need to keep testing it over and over again. Hi Doridu, hi. Did you see my comment? I did a little bit of a redesign of the user page. Alright, let's try it. See what I mean? Now it broke. That's what I meant. Okay. The question is, why did it break? It worked with a single value, it broke with multiple. To be expected from a broken malloc. Also, Ido, do you reckon we could have the... could I make some requests on DB schema changes? Because there are a couple I would like. First of all, adjacent subfields. Second of all, resources having the hash that they can be, or text that they can be referenced to, the UUID. Third of all, a flat. Third of all would be a related to the user reputation-ish table. So the thing that would hold the reputation and their access, so how much access they have, or how many more actions on the website they can take this week. Because I think we should do it on a weekly basis. I think that's it. I've been really popping with website work recently. I wanna stay in the groove. Okay, so it's broken. Why? It's because the next doesn't point to the actual next proper block. That would be the guess, at least. Which is an issue, because it really should. And there's no way for me to actually check the value. Unless I make... a logging functionality that logs a number. Okay, for now we're gonna do it in UART because it's easier. Put PTR. That is actually the one I wanted to do it with. Yes. how am I supposed to do this? resources or elements? That's a good question. I think resources. Relevants are, because the way we plan this out, right? Resources are the wrappers containing the metadata, whereas relevants are representing the papers themselves, the videos, the images, the whatnot, right? Yeah, then I think resources. Because the point of the UUID would be to like have it be referenced or cited, and if someone does the citation, then I imagine they would like to cite the newest one. Or at the very least, resources still allow for history, so even if they don't want to cite the newest one, then still the context of prior versions exist. I have a headache. I have a massive headache. An estimated element is document with data essentially. Yes! Yes. Is there how E and A are upside down? Oh, damn it, you're right, I didn't notice. Ah! Black Thunder, why didn't you tell me earlier? Damn it. I knew something was off about this scene. My goodness. Well, I guess I'll have to proceed with them upside down. I've already rendered too many things. Alright. We have that going. Back to the memory. I need this. Here's the thing. ASCII table. Please tell me digits are next to letters. They're not, because life would be too convenient if they were. Alright, fine. I'm gonna make a new one. I'm gonna call it put hex, and it's gonna take in the char, right? They're exemplar for all. Correct? Yes, that is what they are. Okay, so we want to do it with two different values. First of all, we're gonna have the C and like this. Wait, not if. That's dumb. This is the first value. Oh yeah, if. Not if. What? Am I having a stroke? We wanna No, yes, if. Because if this is greater than 9... Get me back. If this is greater than 9... reference. I'm glad that you're having both sides of this conversation. It really takes a load off my shoulders. Very convenient. We're gonna put C this plus 0, whereas if it's the other case, then we're gonna do the same thing plus A. No, wait, no, we're not. Ah, piss. Minus 10, I think. And then we do the same thing for the other half. I never remember which way the bit shift goes. If you're C bit shift, which way does it go? A is to be shifted, so it's C. We're shifting to the right 4 digits. Okay, great. Now we should be able to just copy this into URH. And we should just be able to use it. So in the kernel, if we comment out all of the things that break our code, and then if after this we try 255, question mark, well, that's not exactly it. Where's question mark? Here. That would be correct if, not for the if, which I so cleverly put there. This should be smaller. Gotcha. I'll put it backwards. FF. That is correct. Alright. Let's try to print all of them. For int I is equal to 0, I is smaller than 255, I plus plus. Okay, so that's broken. All of these are Fs. No, that's not broken. I just didn't put the I in here. That's almost correct. We need to subtract 9, not 10. That's correct. Wait, what? Why 9? Smaller. Gotcha. That's correct. For some reason... Oh no, it goes out to G. I knew there was supposed to be a 10. This has to be a 10, and this has to be equal. Less or equal. Okay. There we go. Now we can print every hex. Except they're backwards. God damn it! Of course the digits go the other way. Okay, bolage. Oh, headache is what it is. I mean, to be fair, it's replacing my headache with a different kind. Like physical with mental. I'll take it. Now what we can do is we can put a hex, which is good because now that we have a pointer, what we will need to do is we'll need to display that pointer. Pointer should be 8 bytes. 1 byte is, which means that what we should do is for char I is equal to 0, I is smaller than 8, I plus plus, and we want to cast it as a char pointer. cast it as a char pointer. I put hex. Okay, so I mean, I'm gonna try it. My hopes are not high. Making a custom char hex and using hex. The problem is, that would be perfectly fine of a solution. That would really work, if not for the question of where would I save that constant? Because you see, it's not quite as trivial as it seems, considering how the constants are saved in the raw data, which I have struggled with in the past. And they tend to be really wacky. The amount of time it took me just to... where is it? There you are. Just to have these constants work is unbearable. And they aren't even constants, they are char pointers, so I actually don't know if they're saved in the raw data. This works just as fine. A little bit of extra logic. It's gonna be slower. I'll take it. I'll take slower for the sake of... as long as it's consistent. Let's try it. Right, you are right. We want a singular pointer. I don't know why I put pointer in there. I think I wanted to pass an address of the variable instead of the variable itself for some reason. Invalid use of void expression. Dereferencing void pointer. No, don't dereference the void pointer. Dereference the char pointer. Trust me. Just close your eyes and pretend it's a void pointer. It's a char pointer. Well, that's something. I mean, it could be correct. It could be correct. It could be correct. No. I mean, Black Thunder, the solution that Menno suggested would be faster. It's just that it's... in this very specific case, it's also more prone to error. How do I test this? How do I test it in a normal way? Can I pass the address of the kernel main? Oh! That looks so wrong. That looks so incorrect. I just realized the logic for this will be the same, regardless if I'm doing it here or I'm doing it on a normal operating system, which means that I can just test the logic first. To find the address P. What? Why address P? P is already a pointer. Okay. We're gonna do that, then we're gonna do print inline %p, I think is valid. Okay, great. And then we're gonna do this. Ampersand should be this. Well, that looks completely wrong. Good. That does look completely wrong. Wait a minute. You might be... That's why, yeah, no. Menno, you're right. That's why I put the pointer in there. Wait, but that won't work. Yes, that will work. Okay. Someone set a reminder for me to never doubt myself. Char pointer, pointer, void pointer, what's the difference? There is no difference whatsoever. Okay, that looks a lot more correct. Okay, you have to be address of. Still completely wrong. Okay, great. X is the hex, right? I'm not just imagining. I don't know, 15, 0F, it is 255, FF, it is something in between, it is, cool, okay. So it should be just a hex, and since we're doing a char pointer, it's always going to be at most 2. And this one doesn't include the leading 0 sometimes, I suppose, which could mean that it could be shorter sometimes, but that's fine. It is shorter, but it's also wrong, so. No, whoops. Hold on. If I do it in the test environment, I can test things more. Alright. Let's get back to it. What am I doing wrong here? Am I going the wrong... Am I reading the pointer completely incorrectly? Why isn't this working? Well, there are a couple of possible reasons. I could be going the wrong way. Doubt that, but hey, simple test. Actually, no. Actually, no. Actually, no. I could be printing it backwards. That wouldn't... No, that wouldn't change it this much. Yeah, it wouldn't. We're missing the leading zeros as well. Yeah, the hex prints it without the leading zeros, obviously. Or the BC. Oh, because the hex trunk is the value. Huh. Interesting. Why are you 4D? This should be the first char of... etc. I mean, yeah, but even the singular byte doesn't appear. Which is a problem. If it was reversed, then it would be reversed in the terminal, which it is not. The values are just completely misaligned. Let's try to do it differently. Casting to a char pointer I like. But casting the address to a char pointer, obviously. Let's try this first. Okay. Well, that is weird. Because this should just print the first byte of the pointer. It very noticeably isn't. This value is contained nowhere in the actual hex. Even my Discord crashed for a bit, out of confusion. Is it because of it being a constant? Oh, that could be. Please tell me that's why. I actually don't care about saying the value. Ah, bless me. Okay. Progress? That does look like progress. The D note aligns, which looks as if we're just going the wrong way. At the same time, why do you print such a massive hash right now? This is meant to be cast as a char for a reason. Print a single char. This is a char, just to remind you. That does not look like a single byte. The D node is correct, the rest is broken, which means that it's actually not correct. And it looks a lot more... Well, it's happening too often to be a coincidence, but it also doesn't make sense for it not to be a coincidence. Also, why isn't it casting to a char correctly? Oh, or is the X always... Oh, never mind. I know why. Okay. That's annoying. That's really annoying. Well, I suppose we could just fix it by ending it with a... Yeah, we can fix it with logic, that's fine. We can fix it by ending it with... 255, bit shifted to the left I amount of times, and then the entire thing has to be bit shifted to the right I amount of times. Oh, we don't need the item. We don't need this. Oh, that's such a much more elegant way to do it, isn't it? If I'm not wrong. And well, if I am wrong, then who's gonna notice? What is your problem? Must have integral type. Fine, long. Just close your eyes and pretend it's a long. Close enough. The D note is right there. D note 06. D note 68. Right here's AC. Hold on. I'm gonna take this. Not decimal binary. And then we're gonna take the first couple of digits of U. Hi, Katsi, hi.
How we doing?
Decent-ish. I can't... I have a problem, I can't seem to... Well, I have a problem which I try to resolve with a little bit of a helper script, which also has a problem which I'm trying to fix.
So your problems have problems.
Yeah. I don't know why.
It can be like that sometimes.
This doesn't make sense.
Where is Black Thunder?
I thought it was here. He keeps chatting,
Yeah,
just in chat, not very
I
much.
thought he was here too.
I'm losing my mind. I genuinely have no idea why this would happen. I mean, this should... Bit shift to right by I. This just takes effectively a mask, sorry. I mean, this would be correct. This should just convert. Like, if we just do long test, just whatever garbage value you have inside works. Okay, well, garbage value is zeros because you're trying to be too clever for your own good. It's too big? It's too big, alright. I don't remember exactly how many digits 64-bit has. There we go. This works. Now, if I just do P with the test, they're way different. Is P trying to be too clever and takes an address of something? No, because the hex. Ah, damn it, no, because then the hex wouldn't align, and it does. Right here, you don't need to cast it long. Only the first byte is correct. It's 4C, 4C. Goodness gracious, this is horrid. I don't know. I just don't know. How does %p work in print? I'm starting to question everything.
Well, I thought this VC would be more touchable. Well, I'm gonna leave you with your problems. Meow.
Okay, so now, so the piece of software we did in order to get information about the system, to see if the system works, now what we need to do is we need to write some more software to find out if that piece of software works. Because so far, hopes aren't really looking up. For some reason, this is printing different value when the %x is done manually versus when it's done automatically. And I have no idea why. Let's try the AR again. Remove all the unnecessary ones. D not aligns. The question would we go the other way? The problem with that is that doesn't make any sense. Like what we could do is we could just cast it to take its address, cast it to char pointer again, then instead of u, just go for -if, D not. Well, that's a problem. The D note is still there. Now the very least pretending to be there. Oh. So we go forward. Well, that's interesting. Well, that's awfully interesting. Huh. Huh. That's awfully interesting. Why did it work this time? What is different? You know what? I don't know. I don't want to know. Well, I do want to know, but it doesn't matter. The point is, as long as we... It doesn't appear to be casted to a char. Either that, or pointers have a whole bunch of unnecessary ones in them, which I don't find likely. Let's do it more manually. How about now? And now I don't know if it's my O, E, AC, 5E. Okay, so first of all, it has to be 8 minus 7 minus I. Okay, that's better. Still not correct, but better. Especially since you delete the leading 0. So if we just copy over the other code for the... where are you? There you are. For you. And right here we can just do print %C. Why the star? Why the star? Where did the star, minus, and plus come from? I haven't got a clue. Fixed. Beautiful. 0D CA 99. Yeah. Yes! Yes! Okay. Oh, finally done it. Okay. Okay. We have it aligned, which means we finally have a script for printing a pointer. And it does look as follows. This. Except in here we just do a P. Yeah. That does look like the address, yeah. That looks awfully correct. That would make sense, right? With the 4 12 00C8 heap start. A bit offset because right here we have a 2, so it's a bit further, like, you know, a couple kilobytes. But who's counting, right? Who's counting at this point? It's Let's try to print the heap. Because the memory H should be defined, right? Oh no, it's not. I removed it. Ah, damn it! I removed it from heap start. I have it here. Void pointer. Memory. Get memory address, and then you will take in a char. Option, which will be if I can do it with a switch. I don't feel like doing it with a switch. Okay. That does not look like the heap start. I'm sorry, but that... Are you certain? I mean, worst comes to worst. I remember I moved it to memory C from memory H for some reason. I don't remember what that reason was, so I suppose we're about to find out. Because otherwise I could just do this directly. Yep. Oh my goodness, char pointer, void pointer, what's the difference? There is no difference. Stop being such a coward. Okay, yeah, that is the heap start. I suppose this is pointless now. We can actually print the pointer of the text, which means that right now what we can also do is we can allocate the other ones and see what they point to. That's a good idea. Broken, got it. That's a problem. Why do you break? I don't... because you very much shouldn't break this easily. You break when trying to malloc something twice. Right, yeah, don't worry. Yeah, don't worry, just... Do you break when trying to malloc something twice, or do you break when trying to malloc something with... No, you break when trying to malloc something twice. Hi there, figure, hi. So the question is, why do you break when trying to malloc something twice? Go here. Current is the heap list. We go in. Current is free. No. The very start of the heap list is not free because it was free on the beginning. And so it was set to 0. So we keep iterating. Current is next. Next is gonna be this. Ooh, that's something I can print. Yeah. I can print... heap list? Next. Heap list undeclared. You are correct. It is. That's a problem. You are correct. But fortunately, it's just the address of the heap start, so that's fine. We can do this. I'm such a goddamn idiot. Block, yes. Run. Compatible pointer type. Why do you care about pointer types? Just don't be a coward. There we go. We have an issue. Next points to all zeros. There we are. Right. Next points to all zeros. Okay. Why? Why does it point to all zeros? It really shouldn't. Void pointer is a headache. I mean, I'm scared to do so, Menno. I am just straight up scared to do so. Because I worry that if I pass an argument, if I take the address of the argument whilst inside of another scope, then I won't actually get the correct address. Oh, so I'm an idiot. This has to be this. No, that's not it. It's this. I'm going to smack you. Correct! Wait, that is correct. Huh. My chair is falling apart. I'll stand up. Wait, that is correct. That is very much correct. Next list. You should be able to make the heads of zero kernel load. Yes, but as I mentioned, the kernel load strings, like the kernel loaded successfully, is more like a constant inside of a call, so it's just stored directly in the instructions. So yes, this isn't associated with the variable, which makes it simpler, and with the other one, they are kind of in a superposition of being constant and not constant. It's my only saving grace. Basically, I need to be really careful here, Menno, and I don't want to add more points of failure. This is already nightmare. This is already a nightmare to debug. Current next is free size, that's correct. It should be able to access it. Next points to the correct address. Because the first one we allocated... Wait, does it? No, it does not. No, it does not. Yes, it does. It depends on what the size of... Oh, Lord. It depends on what the size of the block is. It should be baked in the final thing. You see, that's the problem. It should be. Correct, it should be. However, unless it's a certain yes, I'm not doing it because I'm not adding additional potential point of failure. It should be isn't good enough. Because if it is, then yeah, it makes my life slightly more convenient. Slightly. If it isn't, makes my life a nightmare. What was I about to add? Yeah, I was about to go to the memory and then check the size of the block. Just to double check. SND. $24. So the distance between these two should be 24 plus 6, so 30. 30 is one increase. This went down, that's correct, because it's heap is growing down. Wait, heap is going down, right? I vaguely remember that being the case. That would make sense. Would it? No, it wouldn't. Because right here I'm checking the wrong thing. It should be... It should be you. There we go. C0, C6. Right! Forgot about that. Guess who forgot to add the size of metadata into the goddamn offset? Oh my goodness, that is such a rookie mistake. I don't think it's gonna fix it exactly, but that's still a rookie mistake to catch. So now the offset between them is, we have the heap list, which is C0, and then it's DE, which is 16 plus 14, 30. That is correct. Size of block, which is 24, and size that we allocated, which is 6, which is 30. That's correct. And then we return the current plus a size of block, because we return the usable portion of the block, not the rest. That is unnecessary. Now it still breaks. So I didn't actually fix anything. That was just one of the problems. It's because we don't actually set up the next one. I know why. Okay, it's because we don't set up the next block. Right. So right here we want to initialize the next block. Current next, and then we do is free 1. Size we want to be the rest, effectively. Okay, let's not be dumb here. Let's just... Let's not be dumb here. Let's set it up as a function. So right here we're gonna set up the next one. What do we need to do? First of all, is 3 is equal to 1. Then its size. Next doesn't matter. Size does matter, because size will... Okay, no, we can't do this one. We need to do next, and this actually set up next block. And so this one just takes the current. And the reason why we need that is because... Oh no, that won't work either. Oh, this is such a headache. Basically, the issue is... Let me real paint for this one. Basically, the issue is, if we are just creating memory normally, then it's simple. We create a new block, and afterwards, right here, we need to add the header that sets it to be free, and then the available size being from the beginning of the block till the very end of time. However, if the block we are currently accessing has been freed, which means that it just has additional blocks in the future, then we need to keep in mind what the next block used to be. Actually, no, wait, this is the next block, which means that it's fine. We need to do it in different order. We need to set the size last, because that's the value we already know. Then we don't necessarily want to set the next to be... Let's consider two scenarios. Let's have this as else if, and let's consider a much more optimistic, less likely scenario in which same thing happens, but the size isn't greater or equal, it is just equal. Could happen. And if it is equal, then what? Well, if it is equal, our job becomes a lot easier, because then we just set is 3 to 0. We keep the next block the same. Yes. We keep the size the same. Well, we actually set the size. No, we don't. Yes, we do. Return it. There we go. Next we can keep the same. Which means here we will only be S3 has to be 0 next. Next has to point to the same thing, but right here we need the, yeah. Okay, I think I've done it. Right here we need the size, whereas right here we need current size, which is still the original current size, and then we change the current size. Oh, of course it couldn't work on the first try, that would be too convenient. Do I actually need to draw it out for myself? Am I really that much of an idiot? Okay. We have the current. Then we have the is free segment. Then we have the size segment. Then we have the X allocated bytes. Then we have the next. Once again with I and with S. If this thing is free, Should be current size minus size. I think you are correct. Yes, because otherwise it overlaps. That's not the issue we're having right now, but you are correct, I think. Minus size. Actually, wait, no, not minus size. Wait, should it? There is actually an easier way to do it. And it's a bit dumb. But, and when I say a bit dumb, I mean really dumb. I can just swap these two around. Wait, does this work? I think this works. Next. I think this works. What? It's a block pointer. It's totally a block pointer. Trust me. Trust me, it's totally a block pointer. Oh my goodness, you did actually trust me. I wasn't expecting you to actually trust me. Only to look the same. It's funny. Okay. Oh, I just realized we can print these values. Yeah, I forgot we can just include keywords and just print them. That would be a lot more convenient than printing them here. Oh wait, we're not even testing this. No wait, we are testing this. We are testing this. Never mind. Okay. So before each return we will... This one, the top one isn't happening, but might as well for the sake of consistency. Okay. The fact that you've printed nothing fills me with great hope. Never mind. I take it back. That is actually pretty hopeful. We go right here and we do found place to malocate. And that place is the current. Find place to malocate once and then it dies. It doesn't even start the second malloc. That's interesting. It doesn't even get that far. The thing is, if it's a memory corruption, then it doesn't really matter because it's gonna break either way and all these debugs are absolutely pointless. But I'm desperate, so I'll just chuck in a couple, see where it fails. Who could have seen that coming? My brilliant and beautiful line of code may have some issues. What do you mean it doesn't work? Interesting. Fails on assignment. Well, I suppose I could have seen that coming. Question is why? I wouldn't mind knowing what is your address. Just out of sheer curiosity. There's already block pointer. Well, actually no. You need this. Why can you not take the address of the value? That's not an and. Oh, I hate ambiguity. Come off it. Still an operand. That is you supposed to take an address. You can't take an R value address. What? Why is this the right one? What? This should be a completely valid address. I have the current variable, and all I'm doing is just adding an offset to it. Oh, right. No, you're right. You're right. You're right. My goodness. You are right. I want to print the entire thing. No, I don't. I need to set up a temp. Block pointer, temp, this. Give me the temp. Yeah, I know. DE. That looks correct. That looks awfully correct. But just in case, let's put them closer together. C naught DE. The shift between them is... Okay, this looks correct. Now let's just test one more thing, which is the current next. That is also correct, yeah. Or is it? Ah, I actually don't think it is. It is. It literally is. It is correct. But that does wreck my assumptions a bit, doesn't it? Or does it? I mean, this one looks correct. So then what we're doing is we're going here. Going to this address. This address right here. Treating it as a block. Setting its own next to be a 0. Because some CPUs can use not aligned address, for example, it's 8-byte aligned. It won't work for pointer or something like. It was also 2-byte alignment, so we can't dereference. It should all be aligned to 8. Oh, unless you mean like that. That is not aligned. Oh, I see what you mean. That's a maybe. I feel like this should test it. Menno, you need to join in on these streams more often. That's such a simple fix. First of all, it allows me to keep this line of code, which is possibly the funniest. These two are possibly the funniest 2 lines of code in this entire project, which is great. Second of all, the fix to this is really simple, because all we need to do is just add padding to each malloc block. With each one, we just need to find the closest multiple of 8 to our number that is higher than the number. That's so simple. Which means that the size, on the very beginning, we should just process the size. Oh, I did so many changes to this code, now I don't know which ones are valid and which ones aren't. I'm placing that in process size like this, right? Size is equal to size mod 8 will give us the value that we have. 8, so for example, if it's a 6, this will give us a 6. Then we want to do 8 minus, this will give us a 2, and then plus equals. I broke it. If it's a 0 as well, then it's gonna just allocate 8 additional bytes for no reason. This is bad. What would be good? Wait, it did run beforehand, right? Wait, no, it's not bad, I'm an idiot. I just didn't print it. We have text and another. Text and another, and then print them. Kind of. It's a kind of. The first one's still correct. That's fine. We can just troubleshoot this. We can have the text and then the same thing for the another. See if. Well, yeah, that would do it. That would in fact do it. That would do the trick. If you return just a note, that would in fact be absolutely useless. Why would you return a note? You return a note if current note, but I don't think well, it's not I don't think. I hope that's not it, because that would be annoying. Listen, you know what, let's error this son of a bitch. Couldn't malloc. Yeah, I know. Just there. Okay, so it's not that. Zero, which means Current plus size block doesn't really matter as long as it's broken. Just in case the log is struggling. I wouldn't post myself. Oh! It does say couldn't malloc. It's just that the error is also broken. What? Well, should we fix that? That's a problem. Current plus size plus block will fail because of missing padding. It adds 32. It adds 32 because it's 8 plus 24. The size of block is 24. It's just as aligned. What was I looking for? Oh yeah, right. First, not confuse myself. Beautiful. Great. Couldn't malloc. Which means that you skipped right over the available one. Let's think why. That means the logic inside the malloc is broken. If the current is free and current size is greater than size, current is free should be correct because the next one is free is set to a 1. Current size is set to a size. We don't need the temp line anymore, at least I hope we don't. And since this is a clean 32, that should mean that we should just get 2 digits on the hex. I think. I did the same thing again. Well, we did get the 2 digits of the hex. Make it was right. The problem is that current plus the size of block. Yeah, on the first malloc it does it just fine, no wonder. Then the next is set to E0. What happens on the second one? That's what I'm interested in. Slab allocator, I am not familiar with the name. If you could elaborate. That's interesting. Oh yeah, it doesn't print it on the first try, that's correct. So it only prints the second one, at which point this one is taken, so it doesn't go for that. And the next one, something is wrong. Something doesn't actually let it through the if. Because the second current is free, so it should be... Its size! Oh, its size is set to 0. That's the problem. And then size should be equal to current size minus size of block. I am pretty certain. Completely guessing. There we go! Yes! Okay. There we go. Oh my goodness. Ladies and gentlemen. Ladies and gentlemen. He's done it again. He has done it again! I know. Hold your applause. I know. Thank you. You're all too kind. You can stop with the applause now. Oh my goodness, this is such a pain. But to be fair, this is the single coolest. This right here is the single coolest 2 lines of code I probably have ever done. They are sick. Oh my god, they are sick. This might be my 2 favorite lines of code. Well, I don't want to say ever written. I don't remember most of the code I've written, but this is certainly up there. Because I effectively set this chunk next to be the next of the current. This block's next to be the next of the current block, and then the next of the current block to be that block. Okay. Wow, this is great. I think this is a functional malloc. It's not fast, nor is it good, but it's functional, which is mental. I mean, the thing that's so insane about this is that it's seriously functional. Like, it can free stuff. Well, actually, wait, I should review the free script, because free script was to the old malloc. The current okay, pointer writes... Wait, what? What did you make? I made something useful. Why are you -1? You should not be... Oh, I hate this. Right, I remember why it was -1. That's not the make it cool though. No. We are not doing this way. That's non-descriptive. That is not descriptive. That introduces ambiguity. This entire thing will be cast to a block pointer. However, we are not subtracting from it 1 block. We operate in bytes like serious people. So we subtract size of block. Yes. Is the temp variable on the malloc is already assigned? Is the temp yeah, no, I'm moving temp variable. Come on, I mean, come on. This is so boring. Also, this is faster. I mean, I'm pretty certain the compiler already, like, optimizes it. Optimizes the temp variable out of existence, but this is... I mean, this is proper... Well, not... Okay, I don't want to say proper malloc. Oh, yeah, I forgot to align the size. I mean, we just want to round it up to the nearest 8. How do you do that? I could round it up to the nearest 6... Wait, hold on. This is simple. Wait, this is simple, is it not? Wait a minute. Is equal to size... Oh, it's not quite... Okay, it's not entirely simple. It's almost simple. My thought for a second was remove the... Because if I remove the last 3 bits... Okay, so I'm like, oh damn it. Rounding it down is really trivial. Rounding it up is tricky. To round it down, all I need to do is just remove the last 3 bits. Just undo with a 0. To round it up, however, if I align n plus 7 and unsigned not 7, I mean, at that point I might just return to the previous one, right? This should work. Other than the fact that when it's 0, it allocates 8 extra bytes unnecessarily. I don't doubt that your code works, Menno. It's just that I'm not comfortable with adding code that I myself don't understand, so I need to kind of chew through it mentally to make sure I understand. Because unsigned not 7 should just be all ones and then 3 zeros at the end. So that's equivalent to just doing... That's equivalent to just bit shift right 3, bit shift left 3. Plus 7. Oh, that is clever. Oh, that is very clever. I like that. Yeah. Size plus 7. You do plus 7 to make sure that all of it get added. Then you bit shift to the right by 3 bit shift. Okay. Yeah, and I suppose the undoing with a nod off. That is really clever. That is honestly... That's really smart. Not 7. Yeah. And now we can allocate them properly. So we can do 6, 3, and 8. And it should still work. It does work. What happens if we do more than 8? Yet another. So let's do something crazy like 30. Just to really screw with it. Didn't break. I should remove the log from here, I guess. Or what I could do is I could just do if def debug and if, and now it's fine. Now if the malloc ever fails during development, I'll at least know. Back to the 3. We have the block, we set the 3 to be a 1. Next, block next. Make sure we're not at the end. Next. I mean, this is correct, yeah. I think the 3 is correct. If it is 3, we combine them. While because there will be use 3. Contract once. No, because you will never have 2 free regions next to each other. That's because if 3 is ever next to a free region, the next free region will get assimilated into the prior free region. Free new part, old one still exists. I don't know if I understand what you mean. But I'm kind of tempted to just... There, much better. If it won't do 2 free parts side by side, it's fine then. Well, if there are 2 free parts side by side, they just get merged into a single one. Right, like it frees a block. If the next block is also free, then it not only sets the current block to be free, but also sets the size of the current block to merge into the next block and put the next at the end of the next block, effectively merging them into a single block. And since this is the only mechanism that allows for freeing of blocks, that means that you will never have 2 free blocks side by side. Let's remove all the garbage. Oh my goodness. I'm doing it on my local server and I don't have Git configured there because I never bothered to. So I need to do this. Yeah, good. This is quite progress. Quite some progress. Eventually I need to get Joel to figure out a better algorithm for it. But that should be easier. This works. We have a malloc, we have liftoff. Great. This honestly is a bit insane what we achieved today. I do have to say, Mano, most of the time when people join in on the stream and try to backseat game me on C, I get really upset. But you clearly know what you're talking about, which is a very nice change of pace. Very nice. Okay. I think I might be it for this stream. I kind of got really focused on the OS and, you know, completely stopped with the video work in the background that I still need to do. So I'm going to go now, work on that. And hopefully the videos will be finished soon enough. And for now, that'll be it. Thank you so much for watching and have a great day. Bye.